In this video, I will explain in detail how the derivative of tangent x becomes secant squared x using the limit definition of the derivative, also known as the first principle. We'll use the formula to demonstrate how the derivative of tangent x equals secant squared x. Now, let's prove why the derivative of tangent x is equal to secant squared x. Using the limit definition of the derivative of f of x is defined as the limit of f of x plus h minus f of x over h as h approaches 0. If we define f of x as tangent x, then f of x plus h becomes tangent of x plus h. Using the compound angle formula for trigonometric functions, we can expand tangent x plus h. Tangent x plus y can be expanded as tangent x plus tangent y over 1 minus tangent x times tangent y. So f of x plus h can be expressed as tangent x plus tangent h over 1 minus tangent x times tangent h. Substituting f of x and the expanded form of f of x plus h into f prime of x equals the limit of f of x plus h minus f of x over h. We obtain the expression limit of tangent x plus tangent h over 1 minus tangent x times tangent h minus tangent x over h. The expression may appear a bit complicated. To simplify it, let's multiply 1 minus tangent x times tangent h to both the numerator and the denominator. By doing so, the denominator of the first fraction disappears, and the numerator becomes tangent x plus tangent h minus tangent x times 1 minus tangent x times tangent h, while the denominator becomes h times 1 minus tangent x times tangent h. By multiplying tangent x to the terms in the numerator and expanding, we get the expression limit of tangent x plus tangent h minus tangent x plus tangent square x times tangent h over h times 1 minus tangent x times tangent h. Adding tangent x and negative tangent x in the numerator result in 0, so we can eliminate these terms. Rewriting the limit expression, the numerator becomes tangent h plus tangent square x times tangent h, and the denominator becomes h times 1 minus tangent x times tangent h. Factoring out tangent h in the numerator, we can express f prime of x as the limit of tangent h times 1 plus tangent square x over h times 1 minus tangent x times tangent h. Using the trigonometric identity 1 plus tangent square x is secant square x, we can further simplify the limit expression to limit of tangent h times secant square x over h times 1 minus tangent x times tangent h. Since the limit is taken as h approaches 0, the term secant square x in the numerator is independent of h, so we can bring it outside the limit. Therefore, f prime of x can be written as secant square x times the limit of tangent h over h times 1 minus tangent x times tangent h. Let's replace tangent h in the numerator with sine h over cosine h. This gives us secant square x times the limit of sine h over cosine h times 1 over h times 1 minus tangent x times tangent h. Now let's rearrange the order of cosine h and h in the denominator. Once again, secant square x remains at the front of the limit, and the first term becomes sine h over h, and the second term becomes 1 over cosine h times 1 minus tangent x times tangent h. If we examine the expression on a new line more closely, we can observe that the first term is the limit of sine h over h as h approaches 0. In a previous video, we extensively proved that the limit of sine h over h as h approaches 0 is equal to 1. You can find a link to the related video in the top right corner. For those who need it, please watch the video for reference. Now, using this result, we can simplify the expression of f prime of x to secant squared x times the limit of 1 over cosine h times 1 minus tangent x times tangent h. Here we can examine the remaining terms as h approaches 0. As h approaches 0, cosine h approaches 1, and tangent h approaches 0. Therefore, the expression becomes secant square x times the limit of 1 over 1 times 1 minus tangent x times 0, which simplifies to secant square x times 1. Hence, we can conclude that the expression simplifies to secant square x. Since f of x was defined as tangent x, and the expression we have derived represented f prime of x, which is the derivative of f of x, we have successfully proven that the derivative of tangent x is secant square x. I've been making videos whenever I have a spare time sitting at my desk. However, I'm curious to know if these videos has been truly helpful to all of you, and if there are any areas where they can be improved. I'm also interested to know which countries you are watching the videos from. Please leave your valuable feedback and comments. I would greatly appreciate it. Additionally, if you found this video helpful, please like and subscribe. Thank you all for watching. I've been your Math Guardian, Alex.